the stronger the base. So if you ever find yourself with a solution that turns litmus paper blue and has a pH of 14, you've got yourself a very strong base. Bases are also known to react with acids in a process known as neutralization. This reaction forms water and a salt, which is a fascinating transformation that demonstrates the dynamic nature of chemical reactions. Common examples of bases range from sodium hydroxide, a strong base often found in cleaning products, to ammonia, a weak base used in many household goods. Then there are the alkali metal hydroxides like sodium hydroxide and potassium hydroxide, and the alkaline earth metal hydroxides like calcium hydroxide and magnesium hydroxide. These substances are all bases, and they all have their unique strengths and applications. The strength of bases, often measured by their ability to donate hydroxide ions, make them equally important in the realm of chemistry. These bases, with their bitter taste and slippery feel, are more than just simple substances. They are key players in the chemical world, contributing to the balance and diversity of chemical reactions. The relationship between acids and bases is not just a standoff, they interact in fascinating ways. Just like two dancers in a tango, acids and bases play a unique and interactive role in chemistry. One such interaction is a process known as neutralization. Imagine a heated argument between two people, where one person's anger, symbolized by an acid, clashes with the other's calmness, symbolized by a base. As the argument ensues, the calm person manages to neutralize the anger, and what's left in the end? Peace, symbolized by water, and an understanding, symbolized by a salt. That's exactly what happens in a neutralization reaction. When an acid and a base come into contact, they react to form water and a salt, effectively neutralizing each other. However, not all acids and bases are created equal. Some are loud and assertive, while others are soft-spoken and mild. In chemical terms, the strength of an acid or base can vary. It's not a one-size-fits-all situation. Acid strength is determined by its ability to donate protons, expressed on the pH scale. A strong acid, like sulfuric acid, is a generous proton donor. On the other hand, a weak acid, such as citric acid found in fruits, is a reluctant donor. Similarly, the strength of a base is gauged by its ability to donate hydroxide ions. A strong base, like sodium hydroxide or potassium hydroxide, readily donates hydroxide ions, but a weak base, like ammonia, is more hesitant. But here's the twist: the strength of these acids and bases can change depending on factors like concentration. So an acid or base might show a different strength in a different scenario. This dynamic ability of acids and bases to change their strength and interact with each other, leading to neutralization, adds another layer to the complexity and beauty of chemistry. By understanding this interaction, we can appreciate the dynamic relationship between acids and bases in chemical reactions. We've explored the world of acids and bases, from their properties to their interactive relationship. Let's take a moment to revisit what we've learned. Acids, like the potent fluoroantimonic acid, are known to release hydrogen ions when dissolved in water. They have distinct characteristics, including a sour taste, the ability to turn litmus paper red, reactivity with metals, and playing a part in neutralization reactions. Acids can be as common as acetic acid in vinegar, or as unique as hydrochloric acid in gastric fluid. The strength of these acids is determined by their proton donation, which is expressed on the pH scale. For instance, sulfuric acid is a strong acid, while citric acid found in fruits is considered weak. On the other hand, we have bases. These are substances that can accept protons or donate electron pairs in a chemical reaction. Bases often have a bitter taste and a slippery feel. They can conduct electricity when dissolved in water due to the production of hydroxide ions. They also have a pH value greater than 7. With the higher the pH, the stronger the base. Bases react with acids to form water and a salt, a process known as neutralization. They also have the ability to turn red litmus paper blue. Some common examples of bases include sodium hydroxide, potassium hydroxide, and ammonia. The strength of bases is often measured by their ability to donate hydroxide ions. From weakest to strongest, we have ammonia, alkali metal hydroxides like sodium and potassium hydroxide, and alkaline earth metal hydroxides such as calcium and magnesium hydroxide. It's important to note that the strength of a base can vary depending on concentration and other factors. Remember, acids and bases are more than just a sour or bitter taste. They're complex substances that play a crucial role in the world of chemistry.